So the goal of our project was to determine which situation gives better odds of winning. So first we determined mathematically the probability of rolling a 6 on a fair die and 4 rolls for the first game, because that's how you win. So then we ran simulations by rolling the dice and calculating the simulated probability of winning. Then we compared the results of the theoretical and simulated probabilities. So then we ran the dice to see what gives better odds of winning. And so for the first game, you roll 1 die 4 times to see the probability of rolling a 6. And then for the second game, you roll 2 dice to find the probability of rolling 12 to 6s and the first 24 rolls.
Now the theoretical data here, we calculated the probability of rolling a 6 for the first game, and got a table right here, and this is calculated by taking the probability of rolling a 6, which is 0.167, and then to calculate winning on the second roll, you just take that and multiply it by the probability of not rolling a 6, which is that, which gives you 0.139. And then for each roll after that, you you raise it to the power above the roll that you get, or whatever. So like for the third roll, you would square it. For the third roll, you would raise it to the third, or for the fourth roll, you would raise it to the third power, and then multiply it by 0.167 to get that. And boom. And then the same thing was done. And then the same thing was done for the second game, but we had to use probability of 1 out of 36, because that's the probability of rolling a 12, and then we multiplied that by the probability of rolling not a 12, which was that, and we calculated it in the same way by raising powers and all that jazz. So then over here, you compare the theoretical and actual. So theoretically, we should have a 0.518 chance of winning the first game, but whenever we did it, and we used our data that we got here, we had a 0.422 chance of winning that game. And then the second simulation, theoretically, we should have had a 0.4915 chance of winning, but whenever we did it and we used our data, we had this much chance of winning, 0.4886, which isn't much of a difference.
And see, okay, so in concluding our conclusion, theoretically, the first game gives a better probability of winning, but actually, in actuality, the second game gives a better chance of winning based on our data.
Roll credits.
I can move mountains. I can work a miracle. Work a miracle. That's my cat. Uh-oh.
Yeah. Thanks for watching. Shout out to Miss McCorder for letting us use her room. Okay, bye.